Okay, so let's move towards next concept, that is delegates threads. Okay. Event and event handlers we'll discuss it in GUI program, Windows and web. First, what is a delegate? So for example, you wanted to send something from US to India. Then how do you send it? You have to choose a transmission mode, right? So you will go for some courier. While choosing that courier, you'll have your own specifications, security, speed, and all these things, right? Whoever is sending the gift, so you're going to send the gift, right? So you will become event. And whoever is going to receive your gift will become event handler. And the one who is transferring or carrying the gift from event to event handler is what your delegate. Read me. So delegate is a function pointer. You can, using delegates, you can send communication from one end to another end. And you can pass a complete subprogram as a parameter to another subprogram. Okay, so we usually call it as a function pointer, but this will be used to pass the communication across different events, event handlers, and different threads. Any questions, guys?
No, sir.
Okay, so let's see one example. Okay, so how to define this? So later we will see. We will implement when we implement after completing C#. Okay, I will let you implement application like your WhatsApp. Okay, so there you will see the real use of the combination of delegate, event, and event handler. Okay, the simple example is like you're going to send the gift to your friend, so you will become event. Your friend will become event handler, and whoever is passing that communication and carrying your gift will become your delegate. So using delegate, you'll be able to pass the complete subprogram as a parameter to another subprogram. You'll be able to establish the communication between different threads, different events, and event handlers. Okay, so how to define this? Access specifier. So technically, delegate is a class. Okay, so whenever you want to use a delegate, the object of your delegate has to be created. So access specifier, delegate, and return type. Delegate name, parameters. So basically, as I said, when you talk about parameter, as I said, you can pass a complete subprogram as a parameter. So this definition, this number of parameters that we are providing here should be matched with the definition of a method to be supplied as a parameter. Okay, we'll see one example. For example, access specifier public, delegate, and return type. Return type of the method to be passed as a parameter. And this is like, the definition of a method to be passed as a parameter. Okay, so let's see, let's implement a simple example. Okay, for example, delegate should be declared at your namespace level. Public, you have to use a keyword called delegate and return type. How do I decide my return type? So for example, here I have a method, public static int add of int a comma int b. This is going to return a plus b. For example, this is my subprogram. I want to pass this complete subprogram as a parameter using delegate. Read me. In this case, what is the type of the method? So whatever the method to be supplied as a parameter, the type of the method and number of parameters of the method should be matched with your delegate definition. I mean, public delegate return type. The return type of delegate should be matched with the subprogram to be supplied as a parameter. The return type of your delegate should be matched with the return type of the subprogram to be passed as a parameter. I want to pass add as a parameter using delegate. What is the type of add? It is going to return int. So your delegate return type should also be int. Name of the delegate, you can give any name. Let's say my delegate. Next, number of parameters. Read me. So this should be matched with number of parameters of the method to be supplied. It should be matched. Let's say int a, comma, int b. Okay. So while defining your delegate, first you have to identify like what has to be passed using my delegate. Read me. Which subprogram has to be supplied as a parameter? What has to be passed? First, you have to decide this. So based on this, you have to define your type of your delegate and number of parameters of your delegate. Any questions, guys?
No, sir.
Okay. Now, as I said, now I want to pass add method as a, so not only add with the similar return type, similar number of parameters, you can pass anything as a parameter. For example, here I have public static int product. Return a into b. Okay, so what it will do, like it will look for the return type of the method. It will just check whether return type is matched or not, number of parameters are matched or not. So with the same return type, same number of same type of parameters, you can pass any subprogram as a parameter. Okay, now if I want to pass any subprogram as a parameter using my delegate, so what should I do? So as I said, delegate is a class. So if you want access any property of your delegate has to be instantiated. I'm creating object of my delegate. My delegate obj is equal to new my delegate of. While creating object, it expects the subprogram to be supplied. What do you want to pass? Okay, because it comes with delegate will have a constructor that expects the name and type, the value. Okay, so what are the subprogram to be supplied as a parameter? So it expects that subprogram to be passed during its object creation. Now I want to supply add. Are you to me? Is that is a static method? Public static. Let's keep it in a different class. Okay. When I'm using program reference, this add method and product method. These are available. These are static methods available under class. Okay, when it comes to static method, you can access them directly using its class name. I'm just giving it as class name dot method name, right? So whatever the method to be supplied as a parameter, that has to be provided during its object creation. Okay, now this delete comes with a method called invoke. So what it will do, whatever the parameter is passed during its object creation, it will take care of invoking that method. So while invoking, it will ask you to pass the values for those parameters. So this expects two values to be supplied, right? A and B. If I supply two values, what invoke will do, whatever the subprogram is passed as a parameter, it will take care of executing this program. So whenever you want to execute add, right? You have to supply two values, A value and B value. So in invoke, I'll supply 10, 20, right? So what it will do? 10 and 20, it will execute add. To add, 10 and 20 will be supplied as parameters. So now 10 will be supplied into A, 20 will be supplied into B. It is going to return A plus B. Now I'm going to print it. Console that right line. Sum is okay. Sum is 30. Now I can also pass product. Product is 200. Any questions?
No, sir.
Okay. Next. So later we will see the real use of your delegate. When we implement delegate event and event handlers, there you will see. Okay, it will just take care of carrying the communication from one end to another end. It will take care of establishing the communication between two different things. Okay. Next. Threads. So what is a thread? So simple. In every machine, in every system, whether your laptop or PC, you will have operating system and processor, right? Operating system can be Windows, Unix, Linux, anything, and processor. Who is the master in your system? Operating system. All operations will be managed by your operating system. All instructions will be given by your operating system, right? A processor need to work on something. Instruction should come from operating system. Okay. Let us assume that you started your system. When you open your first application, what has to be done? This application one has to be served. So what operating system will do? It sends instructions to processor. Okay. To start working on this app one, it sends instructions to processor. It will tell the processor, hey, please start working on app one. Let us assume that it has 4 seconds time. Your processor has 4 seconds time. Now what it will do? In your system, you open only one application. So the complete full time, like all 4 seconds will be allocated to app one. So it will be working very faster because it is completely dedicated to only one application. Let us assume that you open your first application .NET. And at the same time, you open another application, some Corel Draw. Now what happens? App 2. It has only 4 second time. In the case one, it has 4 seconds time. It is fully dedicated. It spent 4 seconds for only app one. Now we have two applications. Now processor should serve app one as well as app two. But it has only 4 seconds time. Now what happens? Now your processor operation sends instructions to processor saying that, hey, you need to serve two applications. Now what happens? But technically it has only 4 seconds time. Now this 4 seconds is going to be divided among two applications. So 2 seconds will be allocated to app one and 2 seconds will be allocated to app two. 2 seconds will be allocated to app one and 2 seconds will be allocated to app two. Now both will be served parallelly. Now let's say I opened another application, app 3. And open one more application, app 4. Now what has to be done? Now processor should serve all applications at a time. Okay, in your system, when you open your first application, it will be running very faster. Try to open 3-4 application. Obviously, it will slow down the process. You will see some like it will degrade your performance. You will see some difference over there in the speed, right? If I open 10 applications at a time, obviously all applications will not be working that much faster. It will slow down the speed. Why? We have only one processor. It has to serve all applications at a time. So what happens? Whatever the ideal time that your processor is having, that will be distributed among all applications that you opened. Let us assume that it has 4 seconds time. When I open my first application, all 4 seconds are dedicated to only app 1. That's why it was working very faster. When I open my second application, now this time is going to be divided equally among all your applications. When I open my second application, now this 4 seconds will be divided equally. 2 seconds will be allocated to app 1, 2 seconds will be allocated to app 2. Now both the application will be served parallelly. What happens? Obviously, you will see some difference over there. It will slow down the process. When I open 4 applications, what happens? These 4 will be divided among all 4 applications. And each application is going to have only 1 second time. Obviously, it will slow down your process because all the 4 applications are to be served parallelly. That's why you will see some difference in the speed in your system. All right, to me. So when I open my first application, only first application will be served. Processor will be dedicated to only first application. Right? So technically, when it comes to system, each application will be considered as one thread. Each application will be considered as one thread. These threads will be created automatically by your operating system. Whenever you open any application in your system, one thread will be created, your application will be served within that thread. Then it sends instructions to processor to serve that thread. When I open my first application, I have only one thread created, right? So when your process is maintaining only one thread, that is called single-threaded application. When I open multiple applications, what happens? Each application will be created as a thread. Now 4 threads will be created within the process. Now your processor has to serve all the 4 threads, all the 4 applications. So when your process is maintaining more than one thread, it is called multi-threaded environment. What is a thread? A thread is nothing but a unit of code having its own execution path. What is a .NET application Corel that has been created using some unit of code? Right? If you're executing something in .NET, if you're executing something in Java, if you're playing a video, what happens internally? That was created some piece of code. The code will be executed. So that's what I'm saying. When you talk about application, a thread is nothing but a unit of code having its own execution path. Every thread will maintain their own unique execution path. A unit of code having its own execution path is called as thread. And if your process is having only one thread, that is called single-threaded environment. In single-threaded environment, your application will be working very faster because the processor will be dedicated to serve only that particular application. When you open multiple applications in your system, so multiple threads will be created. Each application will be considered as one thread. So in this case, your process is having more than one thread. So now all threads are to be served by a single processor. Are you getting me? So this is called multi-threaded environment. Any questions, guys?
No.
No, sir.
Now, did you understand the concept of threading?
Yes.
Okay. So by default, whenever you open something in machine, by default, the thread will be created by the system. If that is created by the system, it will be managed by the system only. Right? Now, if you are going to develop an application, right, there also threads will be created by default by the system. All operations of thread, like when to start, when to sleep, when to resume, all operations will be managed by your system, the machine only. So I don't want to do that. I am a developer, right? Rather, I want to take the control over that thread creation. I don't want system to create it. That has to be created by my program, right? If that is created by your program, so you'll be having full control over that, right? If you are going to create it, you'll be having full control over that. right? And you can manage it according to your requirement. Okay, so how do we create our own threads? How do we create a single thread? How do we create multiple threads? How do we start a thread execution? How do we, get them into sleep mode? How can we resume that back? Alright, so these operations, if you want, these operations are to be managed explicitly from your program. If you want to take control over those operations, so the thread has to be created explicitly by you from your program. Okay, so that is what I wrote here. What is a thread? It's nothing but a unit of code having its own execution path. So each process can maintain multiple threads. Here we have seen 4 threads. So when an application is maintaining a single thread, it is called single threaded environment. When a process is maintaining more than one thread, then it is called multi-threading environment. So let's see how to create a thread. So we have a DLL called system.threading. System.threading. So this threading comes with this namespace. This namespace comes with a class called thread. Class called thread. Right? So this class comes with set of methods like stat, stop, resume, sleep. All these are non-static methods. Non-static methods means if I want to access any non-static method, the respective class object has to be created, right? So as I said, we have a DLL called system.threading. It comes with a namespace called system.threading namespace. Now, this comes with a class called thread. So if you want to create any thread explicitly, you have to make use of thread class, right? So if I want to use thread class, I need to get this imported into my programming environment. That is system.threading. Okay. Now I'm going to create my first thread, some T1. You can give any name. Thread object. Thread is a class. As I said, if I want to call any method of thread, this thread has to be instantiated explicitly. When you talk about thread is a class. If I want to call any property of a thread, you should create object of the thread. That is what I'm doing. What is my object name? I'm just giving it as T1 is equal to new thread. Okay, so here it is asking you to pass what has to be executed as part of this thread execution. Array what has to be executed as part of this thread execution. It is asking you to provide that unit of code, what has to be executed. Now you're going to create your own thread, right? So what has to be executed? Whenever this thread is started, what has to be executed? That subprogram has to be supplied, right? Let's create another subprogram. Public, some static, void, print numbers. I'm going to write a print numbers. It will just print numbers for int I is equal to 1, I is less than or equal to 10, I plus plus. Console dot write. This is a simple program printing numbers from 1 to 10. Okay. Now, whenever I call this from main program, I can call something like this, print numbers, right? It will be executed, but here the thread will be created by the system where we don't have control over that thread, right? So that's why I don't want to do that. I don't want to do that. I want to create my own thread. I want to create my own thread. Let's say thread some T1. This is starting. Okay. Simple difference. I can call print numbers from here. Now what happens? Once control comes to your main program, print numbers will be executed, right? But what happens? This print number in order to execute print number, one thread has to be created. Are we creating any thread here? No. By default, thread will be created by the system. Let's see that. What happened? 1, 2, 3, 4, 5, 6, 7, 8, 9. Give right line. Right? What happened? My program got executed. But technically, when it comes to processor, each and every execution path will be treated as a thread. First, it creates a thread and keeps your program into that thread, and that will be executed by your operating system. So by default, the thread will be created by the system. Now I don't want to do that. Rather, I want to create my own thread. Okay, now I'm going to give the control to system. I want to create my own thread. And I want to pass this as a subprogram to this thread. Like here, you have to pass what has to be created within this thread. Are you to me? So I want to create my own thread, and I would like to execute this method within my thread. That is what I'm doing here. Thread T1 is equal to new thread. Okay, you can also give name to your thread. T1.name is equal to T1. Okay. Now, how do I start the execution? Once control comes to here, it will not start the execution immediately. It will just create the thread. Here you have specified what has to be executed as part of my thread. Now you can take the control. Earlier, if I mentioned something like what happens once control comes to your system, thread will be created automatically. It keeps your print number inside that thread, and that will be solved. But here, what happens? It will not be executed. Let's see. Nothing happened. Means your print numbers not got executed. A rating. See, because you're not giving control to your system. You are creating your own thread. You are taking the control over that. You're specifying as part of your thread what has to be executed. Until you say, hey, start it, it will not be started. If I say start, it will start executing this. If I say sleep, it has set of methods like start, sleep, resume, suspend, stop. Read me. Now I can take the control and I can run it. If I want, I can start it. And in the middle of the execution, I can ask him to sleep for 5 seconds, 10 seconds, 20 seconds. I can resume it. I could also suspend the execution. If I want, I can stop in the middle. Read me. So here you can take the full control of your thread and you can drive the execution process according to your requirement. Whenever you want to stop it. Whenever you want to throw it into sleep mode, sleep. Whenever you want to resume it, you can. So you can manage all operations based on your requirement. Any questions, guys?
No.
Okay, now I'm going to start it. T1.start. Now my thread execution will be started. What happens? Here I created my thread and I told my thread like what has to be executed. That's why here I gave the subprogram as a parameter. Okay. Now whenever I start my thread, so what happens? So whatever you put inside this your thread, so only that part will be executed. See, now it got executed. Right? Now, when it comes to this, in the middle of the execution, again, I can take the control. As I said, it is my thread. I can drive it according to my requirement. I can do whatever I need to. Read me. So what I will do, I would like to stop this execution in the middle of the execution. I mean, once it reaches 5, I want to throw that into some sleeping mode. It should sleep for 5 seconds, then restart the execution. I'd like to pause the execution. So if I is equal to, once it starts I want that to sleep for 10 milliseconds or 100 milliseconds. After 100 milliseconds, then you can start executing that. Okay. So for example, I'm doing a process. In one of the process, I sent a request to fetch some file, but I know that the file is going to take 100 milliseconds. In this case, I don't want to divert the control to next line execution, right? Rather, I want to wait for 10 milliseconds or 100 milliseconds. After 100 milliseconds, then check it again. If the file is there, get it processed, then go to next line. That's why I'd like to take the control over readme and drive it. If something is not ready, ask your thread to sleep for 10 milliseconds, 20 milliseconds, then check it. Again, if it is not ready, again ask it to sleep for 10 milliseconds, 20 milliseconds. Keep that repeating again and again until that file is ready. So once it is ready, get that processed, then continue the execution. This is one of the scenario. Okay, like this, if you are having full control over your thread, you can do whatever you want to do. Okay, so here once it reaches 5, I would like to throw that into sleep mode. I want thread to sleep for 10-20 milliseconds. How do I do this? So what is your thread name? Thread to dot. Thread to dot. If I say thread to dot, so whatever thread that is running currently, thread means if I say thread to dot, it will take the current thread, because there will be more than one thread, right? Sleep. How many milliseconds to be slept? So I want this to be slept for 100 milliseconds. Now what happens? Once it reaches 5, the execution will be stopped because you're throwing your thread into sleeping mode. It will sleep for 100 milliseconds. After 100 milliseconds, the thread execution will be started automatically. Are you with me? Okay. Now, I'm just keeping a message. Console dot right line. Thread is sleeping. Right? If I is equal to 6, console dot right line. Thread execution resumed. Okay, now what I'm doing? So if I say sleep, how much time do you want it to sleep? So that time has to be provided. Whether you want that your thread to sleep for 100 milliseconds, 1000 milliseconds, that depends upon your requirement. So now what happens? It will be sleeping for 100 milliseconds. After 100 milliseconds, it will be restarted automatically. You don't have to restart it. Okay, so let's see this. Now can depends 1, 2, 3, 4. That is sleeping. So the time is very less. That's why you can't see here. Let's give it as 10,000. Now what happened? 1, 2, 3, 4. Now your thread is sleeping. Let's put this here above this. Thread is sleeping. Now it will sleep for 10,000 milliseconds. After 10,000 milliseconds, the execution will be started automatically. See, thread execution resumed. What are we doing here? So your main itself is a thread. Your main program will be considered as one thread. Whatever the instruction that you provided inside this, those instructions will be executed as the part of your main program thread, right? So where you don't have control over it. I cannot stop the execution like this according to my requirement, right? But sometimes if you're implementing a parallel program, if you're implementing some asynchronous communication, right? If you want to wait for something to come back, in that case, you need to resume the execution process for some time. There, you need to create your own thread and execute your code within your own execution path and take the control over according to your requirement. In that scenarios, you need to create your own threads and take the control, run them in your own execution process. And not only one thread, you can create a number of threads according to your requirement. Let's say I'm going to create another thread. P2 is equal to new thread of, right? This can be called from n number of threads. I'm going to create another thread which is going to call same T2 dot name is equal to T2. P2 dot start. And I can display the current thread name also. Thread dot current thread dot name. It will be something like, now your execution process is going to have more than one thread, right? If the process is maintaining more than one execution path, more than one thread, this is called multi-threaded environment, where you can create multiple threads and drive them according to your requirement. Or this same method will be executed by multiple threads, thread T1 and thread T2. So thread 1 displayed up to 4, thread 1 is sleeping, and thread 2 started, displayed up to 4, thread 2 is also sleeping. Now both the threads are resumed back. This is called multi-threading environment. Any questions, guys?
No.
Okay. So this is something about your delegates and threads. Next. Next, I'd like to introduce an interface called enumerable. Later we'll discuss more about it. When you talk about enumerable, this is one of the system-defined interface. System-defined interface. Enumerable comes with a method called get enumerator. Get enumerator. Now your list, array list, and all those collections are internally implementing an interface called enumerable. Means they're providing implementation for get enumerator. Why those collections are implementing enumerable? Because you need to navigate through the collections from one record to another record. To implement that navigation, so your get enumerator provides navigation from one record to another record. To provide that navigation, whenever you use for each, right? For each string in my array list, right? So there, the cursor should move from one record to another record, right? So to provide that iteration, to support that iteration, your collections like array list, lists have implemented enumerable, means they have implemented this method in their classes. Okay, so when you talk about enumerable, it is a forward only collection. Okay, so let's discuss one of the important difference, that is difference between a return and yield return. A return and yield return. So far we have seen return, right? we have created a method called, let's say public static. I want to return an array. Okay. Some get data. Okay. If I want to return set of data members, okay, here I'm going to define a variable called int a is equal to new int of, this is my array. Okay. Here actually I should specify the size, and I should ask user to enter those many numbers. And you could also hard code your values. How do I hard code them? Something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. You can also hard code values of your array like this. Now what happens? Here itself we are providing values of array. And based on this, it will define the size. Here we provided 1, 2, 3, 9 elements. So what happens? Internal nine locations will be created, and each element will be placed into those 9 locations. 10, 30. It can mean, right? If you want to provide the elements at the time of declaration, you can provide like this. Otherwise, you can define the size something like 5, right? Now ask user to enter 5 elements. That is one way. If you want to read the elements dynamically at a time, you can go through that way. If you want something to be hard coded while declaring your array, you can also provide like this, right? Now, if I return A, what happens? All elements will be returned at a time, right? So if you use direct return type, here I'm using return, you will be able to return all elements at a time. For example, here I'm going to write a loop. For example, for int I is equal to 1, I is less than a dot length, I plus plus, right? In each iteration, I want to return a different value. Now, what return will do? Return will return only one value at a time. It cannot return multiple values. This will happen only once. In that iteration, whether you can return a single value or group of values, you can return anything, but it returns the value only once. You'll be able to return the value one at a time. You cannot return, you cannot repeat this execution multiple times. I mean, if I keep something like this, for example, here int, now I want to return I want to return I. It's saying it doesn't support, because inside for a return is going to be executed multiple times. In every iteration, it is asking your return to return some value. Return me. So as I said, return keyword returns only one value at a time, like only one element that can have a single value or group of values. It can be anything, but this will happen once. You cannot execute this repeatedly. For example, return 1. Now error will be gone. Now according to this, okay, for example, int j is equal to I. Now what I'm doing, every time whenever the control comes to your loop, your I will start from 1. How many elements are there? 9 elements are there. It will be repeated 9 times, right? Every time what I'm doing, I'm copying I value into j. I'm trying to return j. Now how many elements are to be written? Inside each iteration, I'm copying I value into j, right? If I say return, how many times it will happen? How many values will be returned? Let's see. Console dot right line get data. I'm just calling this. What happened? Nothing. But as I said, when it comes to a return statement, it returns only one value at a time. You cannot get this executed. You cannot get this written multiple times. That is the nature of return keyword. Whether you want to return a single value, a collection or group of value, or a complete class or set of records, that is possible through a return, but you'll be able to return the whole thing only once. You cannot get this executed repeatedly. That is the nature of return. Whether whatever you're returning, whether it is going to have a single value or group of values, you can return anything, but that can be written only once throughout the lifetime. That can be written only once throughout the lifetime. You cannot return multiple times from a single method. If this method is called, this is going to be executed only once throughout the lifetime. So you'll be able to return only one value throughout the lifetime. But here my case is different. My case is different. In every iteration, the I value has to be returned back called to the calling environment. So whenever I is equal to 1, I want to return 1. When I is 2, I want to return 2. Each and every element should be written separately. Right? I mean, for example, here I am doing some process. Step 1 got executed. I got the result. Now I'm working on step 2. I feel like step 2 is going to take more time than expected. That's why I don't want to wait for step 2 to be completed. While step 2 is being executed, I want to return step 1 result back to the calling environment. Why should I hold it? Step 1 already completed. Now working on step 2. Return step 1 result to the calling environment. They will work on step 1 and wait for step 2 to be completed. Once step 2 is completed, return step 2 result back to the calling environment. Then go to step 3. If you use return, you have to wait for all steps to be completed, then consolidate the result, return them at a time. But here, what is my requirement? I don't want to wait for another step to be completed. As soon as my first step gets completed, the result is produced. I want to return that to the calling environment. Next, I will work on step 2. As soon as my step 2 is completed, so I would like to return all the steps results separately. Whenever any step is ready, I want to return that immediately to the calling environment. I don't want control to wait for another step to be completed. So that kind of implementation is not possible to return. If I use return, what has to be done? You have to wait for all steps to be completed and consolidate the result, return the result back to the calling environment. Whoever is calling your method, they should also wait for all steps to be completed. Are you to me? So, but here, I don't want to do that. Here, my process is going to perform the operation of series of steps. Step 1, step 2, up to step 10. As soon as step 1 is completed, return the step 1 result to the calling environment. Next, go to step 2. As soon as step 2 is completed, return step 2, then return step 3. I would like to return the results of all steps separately to the calling environment. I don't want them to wait for all steps to be completed. Rather, I want to return the results of each and every step separately. That kind of implementation is not possible to return, but this is possible through another concept called yield return. Yield return. Yield return. Yield return of I. What yield will do? Once it comes to first iteration, it will directly return this value back to calling environment. You can access it. And when it comes to second iteration, it will return one more result. When it comes to third iteration, it will return one more result. Read me. So if you want to do this, you need a iterator because it has to maintain some space somewhere. So you need an iterator. That's why you have to make use of enumerable. Enumerable of your return type. What are we going to return? We are going to return an integer, right? Now, if I print something, what happens? Whenever it comes to first iteration, I is equal to 0. What is there at 0th position? 10. 10 will be returned back to your calling environment. Next, when it comes to second iteration, one more value. So now we are returning all the values of your array separately. In every iteration, we are returning one separate value back to the calling environment. Run this. Console dot. Oh, I kept it after this. Static. From OBJ is equal to program. So guys, you understood the concept of yield return?
Yes, sir.
Now tell me, what is the difference between return and yield return? Because in many places, okay, especially if you're working on a repository pattern, you will see yield return in many places. So why do we need it?
Return only returns one value at a time.
Okay.
Oh,
Yield return, how does it works?
Yield
oh,
return will run as long as the iteration finishes, but yield return will not run. Will not run with the iteration method.
Okay. Can you give me any real-time scenario? Just think about it.
Okay.
Where exactly we need return and where exactly, like we'd be needing yield return.
When we are using multiple program, okay, in real-time example.
Anything.
yield return. Okay. When we have large data sets, we can use yield return. When example, like if we work on a retail store or something, they will have huge number of data sets, huge rows.
Okay.
Then we can go for yield return.
Okay. So you think about anything. For example, wherever you need to wait for some process in the middle of the execution. Okay. There, let's say you have already completed set of steps and you are waiting for something in the middle of your execution. So why do you need to hold the task which you already completed? Right? If you can return that back to your calling environment, they can do something with that. While they're working on it, you can get another step completed. And as soon as it is completed, you can return it back to the calling environment. Okay.
Like
Use, yeah, go ahead. Go ahead.
yeah, so in this case, we can use it for stuff like authorization codes or something.
Anything, wherever you feel like you need to wait.
Yeah, like login process when we have to enter the OTP. So we have to wait for the OTP.
Right. So if you need to establish some communication between anything, wherever you feel like, you need to wait for something, and I don't want to stop them. See, another person is waiting for something to be written back from your calling environment. Okay. Let's say I call your method. Okay. Your method will perform 10 different steps. I want to know what is happening inside each and every step. I want to know like whether step 1 is completed or not. Next step 2 is completed or not. Step 3 is completed or not. Right. So as soon as the step is completed, you have to pass the communication to me. Read me. So for example, as you said, you're going through multi-factor authentication. Okay. I want to know in multi-factor authentication, first you will enter user ID and password, right? Then you will enter passcode. So if you can send me the communication saying that, hey, step 1 got succeeded. Okay. Here I can also notify the respective people. Hey, you passed through step 1. Now you're going through step 2. Right. So if you use yield return, you will get a chance to pass the communication at each and every step that you're performing.
Okay.
Is it clear?
Yes.
Okay. So that is the use of return and yield return. Any questions, guys, so far?
No.
Have you practiced the previous examples?
Yes.
Any
Yes, sir.
questions from?
No questions from me.
Both of you, Sridhar and Dantu?
No, sir. Do not right now.
Okay, I'll give you some more examples. Okay. Have you created your own components? I told you to write some components.
No, sir.
No.
No.
Both of you. I'll give you an assignment. Please write down.
Okay.
Write a program. To store collection of records of employee. Now, how do you go over it? How do you implement this? Give me an idea. Like We usually store it in the database. When it comes to database, SQL, your database is also kind of a program, right? You're able to store your data in database using a program. If you're storing something in the table, what is a table? Table is nothing but your matrix. Your technically it is a 2D array, two-dimensional array, where it will have a collection of rows and columns. Your first row is going to have all the headers, column names, and rest of the rows are going to hold data. Right now, you know how to create a 2D matrix, two-dimensional matrix. Now tell me, how do you hold it? I'll give you the column names like employee ID, employee name, salary, and gender.
Can you repeat the question, sir?
Employee
How
ID,
How do we hold the records?
program, write a program to store collection of records of an employee. Write a program to store collection of records of an employee.
Employee ID, name.
Employee ID, employee name, salary, gender. Here I give me the idea. Employee ID, MP name, salary, and gender. So how do you implement this?
Can we use lists?
List.
Yeah.
List will take only one element at a time, right? You need to store data in a table format.
Okay.
When you talk about table, what is a table? Table is a matrix. How do you store it? You need to create a two-dimensional array. Okay, with those many columns. How many columns? Here we need to store 4 columns. Rows can be n number of rows. Ask user, hey, how many element records do you want to add? If you say 10, row size is going to be 10, but column size is going to be always 4 only, because you're not going to store only 4 columns. It's in the first row, store the headers like employee name, salary, and store the data from second row. Okay, so you have to do this. If you can complete this, we'll get a lot of knowledge on matrices, class, and everything.
Okay.
And you'll get a chance to know about, like how exactly the data is being stored in the database.
Okay.
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 Okay, right. So let's finish it. So now you are clear about this yield return, right?
Yes, sir.
Okay. You have 2 things here. You can take it in 2 ways. As I said, we can make it static. If I make it static, I can call it directly from the calling environment. If I do not make it static, what has to be done? So the respective class object has to be created in the calling environment. So what is the respective class program, right? If I give something like this, static, I can make a call directly. As you're already aware of these things, right? Get data. Okay. And if I do not make it static, what has to be done? The respective class object has to be created. So I should create the object of respective class. That is program obj is equal to new program. Now obj dot get data. Okay. So here we have a enumerator, right? So technically it is going to return this whole collection, but it is not going to return this whole collection at a time. If you want to return this whole collection at a time, you have to use return. If you want each piece has to be returned at one time, then you have to go through yield return. Okay. So finally, your data is going to return a collection, but not all at a time, right? It is going to send one by one. So you have to take one by one and print it in an environment, whether you want to use it in some operation, print it. So based on your requirement, you can do anything. Okay. So finally, your get data is going to get a collection, but not all at a time. So that's why we have used enumerable. It comes with iterator. What iterator will do? In each iteration, it will send only one value at a time. Okay. So if you want to print it for each int I in, this is going to give you the iterator. Console dot write I. What happened? 10, 20, 30, 40. Every time it will give only one element. Only one element. And if I use static, this is not required. Object creation is not required. I can directly call get data. And you can also pass this number from here. How many times it has to be repeated? For example, I don't want to use array. Rather, I want to get some count int a. For int I is equal to 1, I is less than a, I plus plus. Yield return I star 10. Okay. So basically you can perform anything. Okay. So based on your operations, for example, I'd like to send some range like from and to into from comma int to. Okay. And based on this, I'd like to find out some even and odd numbers. Okay. And return back to them. Okay. So based on your requirement, you can do anything based on your requirement. Basically, if you need to send different results at different times based on your requirement, not all at a time, you can go with yield return. So this is something about your yield return. The difference between return and yield return. Return would return all values at a time, and this will be executed only once throughout the lifetime. But when it comes to yield return, it will be executed for each and every iteration. If your loop is going to repeat it 100 different times, it will be executed 100 different times. Okay. But when it comes to return, no, it is not like yield return. It will be executed only once. So you have to wait for your process to be completed. Once your process is completed, then you have to take the output, return it back to the calling environment. But here it is not like that. In each and every step, you can get this executed and gets the result returned back to your calling environment. That is the difference between return and yield return. This is a very important question. Many interest will ask this question. But in most of the places, we'll be using return only. There are few cases wherever you need to return the result of each and every step. There you can make use of yield return. Any questions, guys?
No, sir.
Okay. And tomorrow we'll be discussing asynchronous programming, exception handling, and then we'll move on to link you. Okay.
Okay.
So these are very small concepts, but it is important when it comes to interview.
Okay.
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 One about this, and we
Go
just have to write a program to store collection of records of employees. The
Okay.
for
Yeah.
using an array.
Yes.
Okay. Okay.
Simple. I'll give you some idea. Define your matrix. Let's say string, right? Employee data. I'm giving it as employee data is equal to new string of row size and column size. Now I don't know. Ask user to enter how many elements does he want to add. Okay. Leave it empty here. We know column size because we are going to store only 2.
No, we are storing 4 columns, right? Employee ID, name,
Okay.
salary.
What is the column size? It is 4.
4.
It is at runtime. 1 second, let me move it. Okay. Now ask user to enter only row size. Int number of records. Console dot write line. How many records do you want to add? These are the core concepts. Okay. See, now return, yield return, thread. So those are all the options. Those are the options that are available in your C#. Now you have to make use of all those options to build something, some product, some component. All right, I mean, here you have to use your due diligence and your intelligence. Okay. Read this. Number of records is equal to, so it is an integer, so convert. Now initialize your array is equal to new string of, what is the row size, number of records, comma column size. We know that we are going to store only 4 columns. Right? You're creating your own matrix, means you're creating your own data to hold, you're creating your own database to hold collection of records of employee. Right? Now, how do you store it? In the first row, it is going to have column names. So employee data of 0, 0. It means first row, first column. It is going to have a header. What is that? EMP ID. In the first row, all columns are going to have headers only. Just keep the headers. EMP name, salary, gender. Right? Now first row got filled. So 0, 0, 0, 1, 0, 2, 0, 3. First row got filled. First row, first column is having header, employee ID. First row, second column is having header, employee name. First row, third column is having header, salary. First row, fourth column, gender. Right? Now, from where should I fill in my data? You should start filling your data from second row. From second row onwards, each row is going to have one employee record. right? Where should I start my main loop? For int row is equal to 1. Row is less than number of records. Row plus plus. It is going to start from row. And inside this, for int, column is equal to 0. Column is less than, how many columns are there? 4 columns. Column plus plus. Right? Here you should ask user to enter these things. When it is 0, ask him to enter employee ID, employee name, salary, gender, and start storing them. Then display them. Okay. I gave you some idea, but you have to create it. This is just basic implementation. Once you're done with this, then I'll let you know how to implement this using advanced things like classes and all. I don't want to hardcode this. Rather, I want to make use of a class. And the entire class has to be stored into your matrix.
Okay.
Okay. So if you start implementing the scenarios, right, you'll get a chance to combine multiple things. See, in this case, you'll get a chance to work with your arrays. You'll get a chance to work with other things. You'll get a chance to work with other things. So think about it, like, think like, how do I create a component, my own component, like array list and other stuff. If you start creating your own component, you'll get a chance to play with too many things. You'll get a chance to play with your threads, delegates, object-oriented programming concepts, arrays, and all these things. Okay. And if I write it here, this cannot be reused. But if I keep this inside a class, what happens? Others can reuse my class, right? So always, if you are writing something, keep it in your own class. Public class employee. Right? If I develop it as a component class, this can be reused if someone wants to reuse it. Right? So now this should be moved to some method. Public void read emp data. Right? Now this method will take care of reading employee data. Now this class can be used by anyone. Whenever someone wants to keep employee data, they can call my method and they can use this for storage. Any questions, guys?
No.
Okay. If no, we'll meet tomorrow. Tomorrow we'll be discussing other concepts. Okay, so whatever I'm explaining, all those are programming concepts. But in order to implement a component, you have to make use of all those programming options. All you have to do is like today we have discussed the use of thread. Why do we need a thread? Why do we need a delegate? What's the difference? When should I go for yield return? When should I go for return? These are all programmable actions. Like if you need to implement something, you would be needing too many things. You need to know what has to be used to fulfill your requirement. So if you're aware of all programming options that are available in a programming language, so when you start implementing your component, you'll get to know like what has to be used to achieve my requirement. Okay. So whatever I explained in the training, do practice at least 1 or 2 examples to learn those concepts, programming options. Then start implementing your component using all those options. That is called advanced level.
Okay.
Okay. Okay, guys, we'll meet tomorrow.
Yeah.
Thank you.